This is Unit 3 Quadratics, Lesson 3.5, Factoring Quadratic Trinomials. So far you've learned how to factor in two different ways. One way is that you found out that you could factor a polynomial by pulling out its greatest common factor. And in the example below, 10x to the third plus 8x to the second minus 4x could be all divided by 2x. So you pulled that out or factored it out and then divided each one of those terms by 2x to get what's in parentheses. Now you're going to be learning that what's left over may not be fully factored. Today we're going to be talking about trinomials. The other type of factoring that you've done so far are the difference of squared binomials, where if you had ax to the second power minus c, where a and c are perfect squares, you were able to factor in the form of, well, you take the square root of a times x plus the square root of c, that all multiplied by the square root of a, x minus the square root of c. And in the example here we have 9x squared minus 64. This is a binomial, and both the 9 and the 64 are perfect squares. So you take the square roots of those two values and make your factored form. In today's lesson, you'll be able to list the factors of a number. This should be a review for you, but it'll help you with the other objectives that you have. One is to find the factors of a number whose sum equals another number. You can identify the four quadratic trinomials and their factored form. And finally, factor a quadratic when a is equal to 1. Before we get into this, we need to review a few things. One is that the factors of any positive number must be either both positive or both negative. So think of it. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. But you could also multiply by all negative numbers to get the factors of 12. For example, negative 1 times negative 12 also equals positive 12. Negative 2 times negative 6 equals positive 12, and negative 3 times negative 4 equals positive 12. So when you're asked to list the factors of a number that's positive, remember they can be all positives or all negatives. The factors of a negative number, though, must be opposite signs. So if you have the factor of a negative 12, you would need like 1 times negative 12 or negative 1 times positive 12. And you can see all the same factors are there, just the signs are opposite. When you add two integers together, their answer is called the sum. And you can either have positive sums or negative sums. If you have a positive sum, then the two numbers that you added together then the larger number must be positive. If you have a negative sum, then the larger number must be positive. It doesn't matter what the other number is, positive or negative, it just matters which one is larger, if it's positive or negative. So it goes back to that rule of same signs add, opposite signs subtract, bigger sign wins. This emphasizes that bigger sign wins. So we are going to be factoring quadratics. Let's talk about this again and review our vocabulary. What a quadratic is. A quadratic is a polynomial when the highest degree is 2. So our largest exponent is 2. And we're not going to be looking at just any quadratic, we're going to be looking at trinomial quadratics. Remember, a trinomial has 3 monomials, or 3 terms. It's a 3-term expression, added or subtracted together. So a quadratic trinomial looks like this. You have 1, 2, 3 terms where the highest exponent is 2. So we are going to be factoring trinomials. To factor a trinomial, it's always the product of two binomials. So you're always going to get two sets of parentheses with two terms, either added or subtracted, inside of them. Right, so that's going to be the basic setup for these. When you're factoring a quadratic, you need to identify the coefficients and constants. A is the coefficient of the x squared term, B is the coefficient of the x term, and C is always the constant, or the number that stands alone. In this example here, let's identify the A, B, and C. So what is A? A is the number or the coefficient in front of your x squared term. I don't see that number, so what is it? It's that invisible 1. So A is equal to 1. B is always equal to the number that's in front of the x term. So in this case it's positive 4. And C is the constant, or number without a variable. Be careful on this one. It is negative 12. Don't forget the signs that go with each one of these numbers. So the key concept here is that when A is equal to 1, like in this example here, then the factored form is determined by the factors of C, so two numbers that are multiplied together that equal C, whose sum, which means if we add them together, equal B. We're going to use this X method to help us find those two numbers, those two factors. Now the signs of our two mystery numbers are going to be based upon the sign of our C value and the sign of our B value. So we will always write our C value in the top of this X and our B value below. If our C and B are both positive, then our two mystery numbers are both going to be positive. If our C value is positive but the B is negative, then our two factors or mystery numbers are going to be both negative. If our C value is negative but the B value is positive, then they're going to be opposite signs, because when we multiply two numbers, the only way to make a negative number is if they're opposite signs from one another. But depending on our B value, it lets us know which number has to be bigger. So if B is positive, then our bigger number, and I'm just going to use a number sign here to represent our number, needs to be positive. So there's our small number and our big number. So we're always going to write our small number on the left and our big number on the right. It really doesn't matter, but you just need to know that the bigger sign should be positive. If our C value is negative, but our B value is also negative, then that means our bigger number has to be negative, and our smaller number then would be positive. So let's practice this. Here I have three examples that I will demonstrate for you. I have a number on top that's 9 and on problem number 1, and a number on bottom that's negative. So which one of our scenarios do we have here? You have a positive over a negative. Whenever the top number is positive, then that means our two mystery numbers are going to have the same sign, or negative. Whatever the bottom number is, that's going to be the signs. So we're expecting two numbers that are negative. The way we find out what our two mystery numbers are is we have to factor our top number. What are all the factors of 9? I'm going to do this off to the side here. Let me see if you can see it right here. Yeah, good. So the factors of 9. Well, what are the numbers when you multiply together that equal 9? 1 and 9. 2 doesn't work. 3 and 3. And there's no numbers in between 3, so we're done. Those are all the factors. But we just got done saying that they all have to be negative. Both the left and the right number has to be negative. So what we're trying to do is find the two numbers that when you multiply together equal the top number, but then when they add together, they equal the bottom number. So let's add these numbers together. Negative 1 and negative 9 are the same sign, so we have to add. It's 10, but the bigger sign wins, negative 10. Negative 3 and negative 3 are the same sign, so we have to add. But the bigger sign wins, so it's a negative 6. Well, that's what we're trying to shoot for, is that negative 6. So those are our two mystery numbers. The two numbers that we want to fill in are negative 3 and negative 3. Let's try another one. I'm going to look at number 2. I'm trying to find the factors of positive 4 that add up to positive 4. So what's the kind of scenario do you have going on there? you have a, let's see where to write it out. So on the top we have a positive number, on the bottom we have a positive number, so that means our two numbers both need to be positive. Positive, positive. What are the factors of 4? They're 1 and 4 and 2 and 2. If we keep them all positive, which ones, when we add them together, equal 4? Well, 2 and 2 do. 2 and 2. So this method is going to be key for factoring. So let's keep on practicing these. Let's try another example, number 3. What kind of scenario do we have here? We have a negative number on bottom and a negative number on top. Top, negative on top and a negative on bottom. Because our top number is negative, then we know that the signs have to be opposite. The bottom number tells me which one needs to be bigger though. The bigger one needs to be negative. So my smaller number has to be positive. So I'm going to have positive, negative. Then I'm going to write the factors of 30. What are they? Factors of 30 are 1 and 30, 2 and 15, 3 and 10. 4 doesn't go into it, but 5 does. 5 and, I ran out of room, just a second. Okay, 5 and 6. Those are all the factors, but we know that our smaller numbers have to be positive, or the left number has to be positive, but our bigger numbers have to be negative. Negative, 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 negative. Now, which pair equals negative 13 when we add them together? Well, it looks like your eyes might be drawn to the 3 and the 10, but look at those are opposite signs we have to subtract. So which one equals negative 13? I feel like I'm missing one here. Oh, there it is. I almost didn't see it. Negative 15 and positive 2. Because they're opposite signs, you'd have to subtract. 15 minus 2 is 13, and the bigger sign wins negative 13. So our two numbers are positive 2 and negative 15. Oops. Back up one. All right, I want you to try these now. There are 6 problems that I want you to find the two numbers that when you multiply together, they equal the top number, but when you add them together, equal the bottom number. Go ahead and push pause, and when you've finished answering all the questions, then push play so that you can check your work. All right, are you ready to check your answers? I'm going to show you the answers one at a time. I'm not going to talk though, so you're going to want to push pause if you miss the problem, so that you can go back and fix your work, and then push play again when you're ready to check your next problem. Problem number 4, we had a negative 84, so that was a negative over a positive. That means we need opposite signs. So our bigger number needed to be positive. 84 has lots of factors. I did use a calculator just to speed this up, and feel free to use calculators on these to find all your factors. And the only one that added up to 5 was a negative 7 plus 12. For problem number 5, you had a negative number on the bottom and a negative number on the top. That means you need opposite signs, but the bigger sign had to be negative. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. But our smaller numbers need to be positive, our bigger numbers need to be negative, and the only one that adds up to negative 5 is positive 3 and negative 8. Some of the numbers are going to be a little bit easier to pick in which factors work, because you just will know them, and that's great if you know them. We don't necessarily mean for you to have to write down all the factors of a number just to find out which one works. But in this case, so 3 and 3, we know, oops, my bad, 3 times 3 does not equal 6. I made a mistake there. Sorry, that's supposed to be a 2 times 3. 2 times 3 equals 6, but 2 plus 3 equals 5. And because you had a positive on top and a negative on bottom, you knew the signs have to be both the same, and they're both negative. Number 7, you have a negative on top and a negative on bottom. That means we need opposite signs, but our bigger sign has to be negative. So that means our smaller sign has to be positive. So we're expecting a positive and a negative number. The factors of 15 are 1 and 15, 3 and 5, and that's all of them. So we put positives on our small number, negatives on our bottom number. The only one that equals 14 are 1 and 15. Problem number 8, you have a negative on top and negative on bottom, which means you should have opposite signs, with the bigger number being negative. 75 has 3 factored pairs, and the only one that adds up to negative 10 is positive 5 and negative 15. And your last question. Question number 9, we have a positive over a positive. Whenever the top number is positive, then the signs are the same. The bottom number determines the sign then. They're both positive. So the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. They're all positive, but the only one that adds up to 7 are 3 and 4. So you have positive 3 and positive 4. Do write the positive signs on these. You'll see why later on in the next steps. If you need more help with these, I believe in your packet there should be another 6 problems that you can attempt to do, and ask your instructor if you need more help, but I'm going to go ahead and go on. So when you're factoring quadratics, when a is equal to 1, you can use these formats. Depending on, they all have 3 terms to them. Our a value will always equal 1 if you're using these forms. That means that there won't be a number in front of your x squared, because we generally don't write the coefficient of 1. So that's why I have that a in gray. So in each one of these, in scenarios, when you have positive on the top and the bottom and both sides, you can see here what the factored forms look like. X plus m and x minus n. So these are our 2 binomials that are multiplied together. The m and the m come from the numbers that you have on each side here, m, and they're always going to be positive. If your top number is positive and your bottom number is negative, remember our top and bottom number come from our c value and our b value. Our c, our constant, and b is our coefficient of the x term always. So if the top number is positive and the bottom number is negative, you're going to have a negative negative. So it's x minus your m value and your n value. If you have negative over positive, then your bigger number is positive. There's your m and n value again. It's always the signs in between will be determined by that pattern. Okay, so there are 4 scenarios here. You see here, positive positive means positive positive here. Negative positive means negative negative. I would use the little symbol here to help you remember the signs of the factored forms. So to factor any trinomial whose any quadratic trinomial whose a value is 1, you will always look for 2 integers, m and n, whose sum is equal to b, but whose product is equal to c. Then you'll write it in the pattern of x plus m and x minus m. So here we have, whenever you have this form right here, where they're both being, all terms are being added together, your c value goes on top, your b value always goes on bottom. So we notice that our c value is positive and our b value is also positive. We're always expecting our m and m value to be positive. So the factored form will always look like this. X plus your m value and x plus your n value. Let's factor some problems, see what I mean. So here you have an example, x squared plus 5x plus 6. First step, let's draw your x. And I'm sorry, I'm not going to use the same steps off to the side here. I'm going to do it slightly out of order. First step, draw your x. Your, sorry, not b, CB, like a truck driver, okay? So your c value is the 12. It's a positive 12, right? Your b value is the 7. You have a positive over a positive, so we expect our m and n values to both be positives. Write your factors of 12. Factors of 12, 1 and 12, 2 and 6, 3 and 4. If they're all positives, because we expect M and M to be both positives, which one equals B when we add them together? Well, 3 and 4 do. So positive 3, positive 4. Our answer, our factored form, would be x plus 3 times x plus 4. And that is your final answer. We got those from our two magic numbers that we just tried to find, whose factors equal 12, but whose sum equals 7. Sorry, I think I skipped over the first focus question, but we can do the same thing. So if step 1 is identify, oops, that's why, because I forgot to hit my pen tool. So our first step is to identify our B and C. I always flip it around, identify your C and your B so that you know with your top number, your bottom number. Our C number is positive 6, our B number is positive 5. Because we have a positive over a positive, we're expecting our numbers to both be positive. So we would need a positive. Factors of 5, or factors of 6, sorry. The factors of the top number, 1 and 6, 2 and 3. If they're both positive numbers that equal B, that's the 2 and the 3. 2 plus 3 equals 5, but 2 times 3 equals 6. Your factored form would then be, you make two sets of parentheses, whatever variables in the problem. Here we have x, so we're at x, and plus 2 and plus 3. Alright, back to focus question 3. Sorry for the jumping around there. Alright, same thing here. We had the same factored form where we have all of our terms are positive. So you identify your C value and your B value. C is equal to positive 20. B is equal to positive 21. They're both positives, so you expect positive and positive form. So we already expect that our answer is going to be the variable, which in this case, and be careful that this time they use the letter G. So we already expect that this is going to be G plus some number. So again, we find the factors of 20, our top number, 1 and 20. 1 is always a factor. 2 and 10. 3 doesn't go into it, so I don't write it down. 4 and 5. And I know to stop there because there's no numbers between 4 and 5. So those are all the factors. That's how I can tell when I'm done. I'm expecting positive and positive, so they all stay positive. The only ones that equal up to 21 are 1 and 20. So you put 1 and 20. If you already knew or were able to pop it in your head, of course, you don't need to write down all the factors. Alright, now it's your turn. Do all 3 of these problems on your paper. Push pause and do all 3 of them. And then when you're ready to check your answers, push play again. And I will have all 3 of them worked out for you. Ask an instructor if you don't know why you missed one of the problems. So in all 3 of your problems, you had a positive over a positive, so your answer should always be positive. You can push pause while you finish checking your work and correcting your mistakes. When you're ready, push play. There may be another slide of more practice problems on your paper that you can do on your own if you need additional practice. Let's take a look at the second scenario. In the second scenario, you will have a positive C value but a negative B value. In all of these cases, if you have positive over a negative, you expect your 2 factors to be negative. Therefore, the pattern or the form of your factored form will be your variable minus your M and your N value. So these are very similar, exact, you solve them the same way as the ones before. The only difference is both the terms will be negative. So let me demonstrate a few of them for you. So once again, we make our X. We need to know our C and our B value. So our C value is positive 45, but our B value is negative 14. So that means we have the scenario of positive over negative. That means we need both negative numbers as our factor pairs whose sum would equal 14. Just like before, we write down the factors of 45, or our top number, 1 and 45, 2 and, well, 2 doesn't go into 45, it's not even, so it can't go into it. 3 does, though. 3 and 45 divided by 3 is 15. 5 goes into 45 9 times. 6, does 6 go into it? 45 divided by 6, actually it can't. If it can't be divided by 2, it can't be divided by 6. It's one of the divisibility rules. 7 doesn't go into 45, and then 8 doesn't either, so that's it, that's all of them. We know they all have to be negative answers, so the only one that equals up to positive, or to negative 14 is negative 5 and, oops, that can't be, yeah, that's right. Negative 5 and negative 9 do add up to negative 14. Same signs add. So our final answer then is x minus 5 times x minus 9. Focus question 2. These are all going to be the same format here. So we have a C of a positive 24 and a B of a negative 10. That's positive over negative. That means we're expecting 2 negative numbers. The factor pairs of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. There's no numbers between 4 and 6 that multiply together to equal 24. We're expecting all of our numbers to be negative. And we were trying to find out which one has the sum of negative 10. Well, that would be negative 4 and negative 6. Negative 4 and negative 6. So our final answer would be x minus 4 times x minus 6. Last example. Alright, make our x. Identify your c value as positive 2. Identify your b value as negative 3. So again, we have a positive over a negative, so we expect 2 negative numbers. The factors of 2 are just 1 and 2. That's your only choice. So that means your answer would be, and be careful up here, always check to see which variable you're using. We're using the letter m this time. So you want m minus 1 times m minus 2. Alright, once again, I've given you a few guided practice problems that I'll let you check. If there's any more on your packet, then that's just extra practice if you need additional help. So go ahead and go ahead and try all 3 of these problems. Push pause until you're done, and then push play to check your work. Okay, here's your answers. You can push pause until you are done checking all your work. All of these were examples of when you have a positive over a negative, or when your C value is positive and your B value is negative. Now we're going to be looking at trinomials when there's a negative in the back, or whenever C is negative. This is the time when we have to decide which number is bigger, is the sign that gets the positive or negative sign. So in both of these cases, we're going to be looking at where C is negative. So we have 2 scenarios. When C is negative, if it's positives on bottom, then our bigger number is positive. If negatives on bottom, then our bigger number is negative. That means the opposite would be, positive. So your form, even though it says x plus m and x minus n, your forms are really going to look like this. You're going to have x minus m and x plus n, or you're going to have x plus m times x minus n. So let me demonstrate a few. We start off again by drawing your x, identifying your c value over your b value. So what scenario do we have here? We have a negative over a positive. Because the negative's on top, we need opposite signs, and whichever your bottom number is positive, so we want our bigger sign to be positive. That means our other sign has to be negative because they have to be opposite signs. So we're expecting a negative and a positive number where the smaller number is negative. Then I write the factors of my top number. My factors of 5 are 1 and 5, well, and that's it. I'm expecting my smaller number to be negative and my bigger number to be positive, and that's my only choices, so I have 1 and 5. So my final answer would be x minus 1 times x plus 5. Hope you don't think that's too bad. Let's try another one. Or too difficult. So same thing again here. Draw your x, identify your c value as negative 60, identify your b value as negative 4. So the scenario we have is a negative over a negative. Because the top number is negative, we want opposite signs, but the bottom number tells me which one needs to be bigger. The bigger number needs to be negative. My smaller number needs to be positive. So I'm expecting positive, negative. I write my factors of my top number. Top number is 60. The factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15. Yes, I used a calculator. 5 and, it does go in there, 12, 6 and 10. I did run out of room, so I'll write my answer somewhere else for you. 6 and 10, 7, 8, that's all of them. So I'm expecting all my small numbers to be positive and all my larger numbers to be negative. And I'm trying to find which pair equals negative 4 when I add them together. And that would have to be my positive 6 and my negative 10. Positive 6 and negative 10, because 10 minus 6 is 4, and the bigger sign wins, so it would be negative. Your final answer then would be, try to figure out where it'll let me write it. I'm going to write it up here in the top for you. Would be x plus 6 times x minus 10 is your final answer. Oops. There we go. Minus 10. Need one more? Oops. Put my pen back on there for you. Alright, let's try one more here. Make your x, identify your c over b, your truck drivers here, CB. Alright, you have a positive number on top and a negative number on bottom. Oh, this one's tricky here. They fooled you here. You have a positive on top and a negative on the bottom, so you're expecting negative and negative. Negative and negative. Factors of 2 are 1 and 2. And that's it. That's the only factors, and we're expecting negative and negative, so we know it has to be 1 and 2. So our answer is m minus 1 times m minus 2. You can always check your work by either stacking or using your box or using the FOIL method to multiply those two values together to see if you get the original polynomial. So I have some questions for checks for understanding for you. Question 17. Circle the numbers whose factors you want to find. The factors you want to find. We always want to find the factors of our c value. So we want to find the factors of negative 72. Don't forget those signs there. There's our a value, b value, and c value. Circle the sum of the factors. I think it's what we want to find. The sum of the factors we want to find is our b value. So in this case, we want it to sum up to negative 1. Which of the factors has the greatest absolute value, the negative factor or the positive factor, and how do you know? Well, that's a very confusing question. I think it makes it easier if you do this. Negative 72, and we want it to be a negative 1. So our bigger sign has to be negative, and our smaller number needs to be positive. So they want to know which is going to be your negative factor. How would you describe which is going to be bigger or smaller, I guess. So let me write this. Best way to write this would be I would expect the absolute value of the larger of the negative factor so which factors have the greater absolute value. It was about the negative factor, because there's probably a better way to write this, but hopefully you kind of understand what I'm trying to get at, because bigger sign wins. Because bigger sign wins. Let me think for a minute if there's a better way to write that. Okay, so I rewrote this, and probably the best answer that you could possibly say here. The negative factor has the greater absolute value because the coefficient of x, which we often refer to as b, is negative. Question 20. Write the pairs of negative 72 and circle the pair that equals to negative 1. Alright, the pair factors of negative 72. So they wrote these out horizontally, as I've been usually doing them vertically. Negative 72, I like to do it this way. So the factors of 72 are 1 and 72. Does 3 go into 72? So, it should. 72 divided by 3 equals 24. I knew that it should. If you know the divisibility rule of adding the digits together, do you know this rule? If you add the digits of a number, like 7 plus 2 equals 9, if that number can be divided by 3 without any remainder, then that means the big number, 72, can also be divided by 3. It's a cool trick. Oops. So 3 and 24. 72, can it be divided by 4? Yes, it can. 4 and 18. Can't be by 5. Can't be by 6. 7. Can't be by 7. It can be by 8. It's 9. I knew that. Just trying to get these done. Alright, 8 and 9. And that there's no numbers between 8 and 9, so those are all the factor pairs. So 1 and 72. 3 or 2. Oh, I forgot 2. 2 and it's an even number, so you should be able to divide by 2 is 36. 2 and 36. 3 and 24. 4. See, if I would have used the guide down there, I would have known which numbers to look for. Oh, I missed 6 too, because I missed 2. 6 and if a number is divisible by both 2 and by 3, then it can always be divisible by 6. That's another divisibility rule. 72 divided by 6 is 12. 12. And then by 8 we found out was 9. But we want to make sure that their sum equals to a negative number. So we want the bigger numbers to be negative in order for their sums to be negative. So, why do they have, just a second. Okay, I see what they did there. So they want all the factor pairs of negative. So there's all these can be negative. Or you could have reverse, where the positive numbers or the smaller numbers are negative. But we know that we are looking for a negative number. So I'm not going to fill in all the other ones. You would just have to duplicate all the numbers. So the factored form of the expression would be x. We know we want plus minus. And then which pairs equal to -1 when we add them together? Well, that would be the 8 and -9. So 8 and -9. Oh, they say something about a rectangle. Okay, so we're applying this. It says the rectangle area is this. What are the possible dimensions of a rectangle? Well, the word area means multiplication. It's like what two numbers, if you have a rectangle, what two numbers can you multiply together to get that rectangle? Sorry. Our length times our width there. Well, our length times our width must be our expressions. So our two dimensions of the rectangle, well, our length or our width could be x plus 8, where our other dimension is x minus 9. So I have one final, these are all mixed, all different types, 3 problems for you to try, and then you can check your answers with me before you do the independent practice worksheet that you must turn in for homework and will be graded on. So go ahead and try these 3 problems and then push play to check your work. Okay, I tried to show each one of my steps in a different color there, starting with the blue, identifying my C and my B, and then the purple to identify what signs that I needed. Then I went to green to find all the factors of the numbers, and then finally in red to determine which factors equal B. Then write it in factor form. In all of these examples here, your C value was negative, so the bigger sign begot the negative or the positive depending on your B value. You can push pause to finish checking your work, and when you're done, push play. So just a recap real quick, this method of drawing your X to find your two factors whose sum equals the B value only applies when your A value is equal to 1, and it's only for trinomial quadratics. So that's the end of this lesson. Go ahead and do the independent practice problems.